Okay, so let's do a problem like number 8 in the worksheet 8.5. And so I've rewritten it a little bit, and it says that we have 105 milliliters of potassium phosphate, and it's evaporated until, oh wait, this should be sodium, sorry, sodium phosphate, and it's evaporated and we get 7.54 grams of solid sodium phosphate were recovered. What is the molarity of the original solution? So I have a certain number of grams and I can convert that to moles. So it's going to be 7.54 grams of Na3PO4. And I've already calculated the molar mass of that just so it didn't take up time. And that's 163.94 grams of Na3PO4 for 1 mole, Na3PO4. And I want to know the molarity, so I have to convert these milliliters into liters, so I divide that by 1,000 or move the decimal point 3 places to the left, and so that's going to be 0.1050 liters. And so grams of NaPO4 will cancel, and I will have moles divided by liters, and that'll give me my molarity. So it's going to be 7.54 divided by 163.94 divided by 0.1050 equals. And so the original molarity was 0.4380 molar. And then rounded, we have 3 significant figures, so it's going to be 0.438 molar Na3PO4. So I'm going to go ahead in this video and go ahead and do this second type of problem. Somebody asked for 8 through 11, 9 and 10 are more thinking questions, and I think I discussed those, so I can do that in a separate video. But for the second calculation, I figured I might as well combine it in this video. So this one is like question number 11 in the worksheet 8.5. So it says 1 grain of sugar with a mass of 3.350 milligrams is dissolved in a certain volume swimming pool. Determine the sugar concentration. So it's asking me to find molarity. And then use it to determine how many molecules. So then I have 2 answers I need to produce. So let's start. I think I'm going to go ahead and do the volume first. So the volume is going to equal length times width times height. But the only conversion I know between centimeters or meters and a volume is that 1 milliliter equals 1 centimeter cubed. So I'm going to make all these into centimeters. So I'm going to multiply by 100 or move the decimal 2 places to the right. So my volume is going to equal 1500, and that's centimeters, times 1600 centimeters times 300 centimeters. So 1500 times 1600 times 300 equals, let me put that in scientific notation, that's too many zeros. And so that's 7.20 times 10 to the 8th centimeters cubed. And 1 centimeter cubed equals 1 milliliter. And there are 1,000 milliliters in 1 liter. And so divide that by 1,000, or reduce that exponent by 3. 7.2 times 10 to the 5th liters, because milliliters cancel with milliliters, cubic centimeters with cubic centimeters. So I have my volume in liters. Now I need to get my grams into moles. And like before, I went ahead and calculated the molar mass for sugar, sucrose. And so I'm going to start with my 0.350 milligrams of C12H22O11. And there are 1,000 milligrams in 1 gram. And there's 342.296 grams in 1 mole. And then dividing that by the answer we just got will give me my molarity. So 0.350 divided by 1,000 divided by 342.296 divided by, and since I have it here, I'm just going to hit second answer, equals, and I get 1.420 times 10 to the negative 12th molar, which would be 1.42 times 10 to the negative 12th molar, and that's one of the two answers I need. Now the second answer is I'm going to take this number and convert it into how many molecules in one drop. So the other conversion you need to know is that in 1 milliliter equals 20 drops. So I'm going to use that. So I'm going to start with 1.42 times 10 to the negative 12th moles in 1 liter. And there's 1,000, or there's 1 liter is 1,000 milliliters. And in 1 milliliter, there's 20 drops. And then in 1 mole, there's 6.022 times 10 to the 23rd molecules. So I'm going to slide this down a little bit. And so I'm going to start with, you can't see it there. Now you can see it. So I still have this answer here. I'm going to use that because it's the starting point here. So I'm going to divide by 1,000. And then I'm going to divide by 20 drops. And then I'm going to multiply by 6.022 second EE23 equals. And I get that there's 4.276 times 10 to the 7th molecules in a drop. And so still have 3 significant figures, so this is going to be 4.28 times 10 to the 7th molecules in 1 drop. Okay, I hope that helps. Let me know if you need something else. Thanks.